Hey YouTube, in this video we're going to be looking at question number 2 from the CSMC 2015 math contest. If f of x equals x over x minus 1 for x does not equal 1, determine all real numbers r does not equal 1 for which f of r equals r. So in this question we need to solve for this equation here, f of r equals r. So if we have f of r, that means we just take this equation f of x and we're going to substitute every x we see with an r. So that gives us f of r equals r over r minus 1, and this is going to equal to r. Okay, so let's try to solve this equation for r now. So I want to get rid of this denominator, so I'm going to multiply both sides by r minus 1. So I get r equals r times r minus 1. We don't actually need the f of r here on the side. And now I see I might be able to get a common factor r if I subtract r from both sides. So I get 0 equals r times r minus 1 minus r. And yep, there's our common factor. I see an r in this first term, I see an r in the last term. So I'm going to factor out r. 0 equals r times r minus 1, because r times r minus 1 gives us this first term, and then minus 1. So yeah, r times r minus 1 in brackets gives us this first term, and r times negative 1 gives us this last term. And now I just want to expand what's in the brackets. So I get r minus 2. So that means either r equals 0 or r minus 2 equals to 0, because one of these needs to equal 0. And then for the right factor, I'm going to add 2 to both sides to get r equals 2. So we determined all real numbers r does not equal 1 for which f of r equals r, and the solutions are r does not equal 0. R does equal 0 and r equals 2. Okay, let's move on to the next question now. If f of x equals x over x minus 1 for x does not equal 1, and the reason f can't equal 1 is because if we put 1 in the denominator, we're going to get division by 0, which isn't allowed. Show that f of x equals x for all real numbers x does not equal 1. Okay, so when I see a question like this, f of x, this is a composition of functions, and the strategy I like to use for this kind of questions is to find the inverse of f of x. If I have f of x equals to x, and then I take the inverse of both sides, I get f of x equals the f inverse of x. And that's because the f inverse cancels out with the f here, and then we just get f negative 1 of x on this side. So let's try to find the inverse of this function. So I'm just going to write this out as y equals x over x minus 1. And now I'm going to switch all the y's with x's and all the x's with y's. X equals y over y minus 1. Now I'm going to multiply both sides by the denominator, y minus 1. I'm going to expand the left-hand side now. And now I want to get all my y terms together. So negative x equals y minus yx. I'm going to factor out the y from the left-hand side, from the right-hand side, I mean. And then I'm going to divide both sides by 1 minus x. So negative x over 1 minus x equals y. And this y is actually the f inverse of x equals negative x over 1 minus x. Okay, so let's set this equation equal to that. X over x minus 1 equals, what was that? Negative x over 1 minus x over 1 minus x. Now these two equations are pretty similar. I noticed in the denominator I have x minus 1 on the left side and 1 minus x on the right side. So I'm not going to change this, the right hand side, but I'm going to make it equivalent. I'm going to use an equivalent fraction by multiplying it by 1, or negative 1 over negative 1. Because negative 1 over negative 1 is the same as multiplying by 1, which doesn't change anything. And it's going to give me the same denominator, x minus 1. So now I get x over x minus 1 equals negative x times negative 1 is x over negative 1. I'm going to multiply the x first. Negative x times negative 1 is x, and negative 1 times 1 is negative 1. And now we see that x over x minus 1 equals x over x minus 1. That means this is true for all real numbers x, except for x does not equal 1. That would give us 1 over 1 minus 1, which equals 1 over 0, which is undefined. Okay, thanks for watching, and like and subscribe. See you next time.